So we've got the force, then we need to find the acceleration. By the way, with the force, again, I've used just the magnitude of the charge and the magnitude of the electric field strength, but a similar deal to what we were talking about with QV. We could say because the electron is moving against the electric field, and the electron has a negative charge, we could put negative signs in front of both the 1.6 and the 40 there, but we'd end up with the same magnitude anyway. In VCE exams, as long as you are being consistent and clear with what you're doing, you would be fine in either way you go about that. Okay, so find the acceleration of the electron. Well, now we can use Newton's second law and say acceleration is equal to force, net force, but that is the only relevant force in this case, divided by mass. So we have 6.4 times 10 to the negative 18 divided by the mass of the electron, 9.11 times 10 to the negative 31. And that should give us, I believe, 7.025 times 10 to the 12 meters per second squared. Now, that's more significant figures than we have for the values that we're using. So if this was our final answer, I would give this to only 2 significant figures. However, this is not our final answer, so it's helpful to keep a couple of extra significant figures up your sleeve when you have calculations that are continuing on, so you don't end up rounding too early and then having an incorrect value at the end. So we'll carry that through with the 4 significant figures. So now that we have the acceleration, we can now use step 3. We can use our constant acceleration equations. So, what do we know? So just write down SUVAT. I apologize, I'm really getting tight on space here. So T, that's what we want to know, so we definitely need that in the equation. Acceleration, we needed to know, and we have calculated that now, 7.025 times 10 to the 12. V, we do not know, but we also don't really care, so that's probably going to be one we exclude. U, we know it starts from rest, and S is the distance that it travels, and we know that distance is 50 centimeters from the beginning of the question. So we can use S, U, A, and T. So that would give us, so S equals UT plus half AT squared. So we know, I'm just going to create another little boundary here. So we know 0.50 is S, UT, well U is 0, so that whole term disappears. And we have half times 7.025 times 10 to the 12, getting very tight, times T squared. The half here kind of cancels with the 0.50 on the left. That doesn't mean the 0.50 turns to 0 on the left, it means it turns to a 1. So we're kind of dividing by half or multiplying by 2 on both sides. And so T is going to be the square root of 1 divided by 7.025 times 10 to the 12, which gives us, I believe, I very much hope, 0.377 times 10 to the negative 6 seconds. I'm now going to give the number just to 2 significant figures, so that is 3.8 times 10 to the negative 7. Just try and make that 7 look clear.